So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of AQA GCSE Maths Foundation topic tests with the focus of factors and multiples. Now as always, there'll always be a copy of the test in the description below for you to download and have an attempt at either before watching this video or while watching this video as we go through the answers. Now before we get started, it's worth noting that there is no indication about which questions are non-calculator and which ones are calculator. So what we'll do is we'll just assume that they're non-calculator, and if they do appear on a calculator paper, by showing full working out, you'll just do that working out on your calculator. Now for the lowest common multiple and the highest common factor, you may want to opt for a factor tree if it's on a non-calculator paper, but if you've got a Casio calculator, there is a function on your calculator that allows you to write numbers as a product of their primes, and again I'll show you this on when we come to that particular question. So looking at question 1, it says circle the number that is both a multiple of 3 and a multiple of 5. So we're looking for a number that appears in both the 3 times table and the 5 times table, and given our choices, the correct answer is 30. Then moving on to question 2, it says circle the number that is a prime factor of 189, and the correct answer you should have is 7. Now to check if it's a prime factor, again all you want to try and do is just try and divide 189 by each of those numbers. We know that 189 is definitely going to be a factor, but it's not prime. And also if it's on a calculator, then all you need to do is just simply type in the number, press shift fact. If it's on a Casio calculator, it will give you product of their primes, and then from there you'll be able to see which numbers you can make to that's on your list. Moving on to question 3, it says burgers are sold in packs of 6, buns in packs of 10. Liam wants to buy the same number of burgers as buns. Work out the smallest number of packs for each item he could buy. So the first thing we need to establish is what is the lowest common multiple of 6 and 10. So what's the smallest number that appears in the 6 and the 10 times table? And the correct answer you should have is 30. So if I want 30 burgers and they come in packs of 6, then I'm going to need 5 packs. And to get 30 buns and they come in packs of 10, to get 30 I'm going to need 3 packs. So in the answer box, all I need to do is just write 5 and 3. Moving on to question 4, it says here is a menu. We've got starter, main and dessert. Beth chooses a starter and a main. List all the possible combinations she can choose. The first one has been done for you. So for this, what we want to do is just looking at starters and main, so we can ignore the desserts. Now I would always recommend you doing this in a systematic way. So we're going to start with soup and we're going to change our mains. Now curry is already done, so let's do soup and roast and soup and pasta. Then we move on to melon, and that's going to be CRP. And just write an M there. And then we move on to juice. Don't know who would have juice as a starter, but there you go. Each their own. And JR and JP. So altogether there are 9 combinations. And another way, if it was just asking how many combinations are there, we can just multiply the number of options by each other. So it's going to be 3 times 3 for starters and main, which gives us 9 combinations. But the list is basically what the question is asking for. Question 4, it says Chen chooses a main and a dessert. How many more possible combinations can Beth have than Chen? So here we're looking at main, and there are 3 options, and for desserts there are 2 options. So all in all, the total number of combinations is going to be 6 combos for Chen. Now if Beth has got 9 combinations, then the difference is going to be 9 minus 6. So the answer then is going to be 3. Moving on to question 5, it says that Mo says any common multiple of 2 and 4 is always a multiple of 8. Give an example to show that Mo is incorrect. So here what we want to do is find multiples of 2 and 4, and which 4 is a multiple of both 2 and 4, but not 8, because the lowest multiple of 8 is going to be 8. So, but not 8. There you go. Then for question 6, it says A, B, and C are different prime numbers. Work out the set of values for A, B, and C so that A plus B equals 2C. Now again, there are several different combinations you can go for. I'm not going to go through all of them, but I would say the most common probably answers are probably the smallest ones. So you can have A equals 3, B equals 7, and that equals and C equals 5. Because 3 plus 7 is 10, and that's 2 lots of 5. Another combination you could have is A equals 5, B equals 17, and C equals 11. And again, there are several combinations you could go for, but I would say those two are probably the most small ones that contain the smallest numbers. Now, moving on to question 7, it says that a number is an odd multiple of 3 and has a common factor of 180 and 750. Work out the greatest possible value of the number. So for this, what you want to do with these types of questions, you always want to write down a decent amount of examples for each category. So if we go for the odd multiples of 3, now the quickest way you probably do that is just to write down the 3 times table, because it's again very easy to do. And so on. And what we want to do is just make sure that we're only wanting the odd numbers. So I get rid of the 6, get rid of the 12, get rid of the 18, get rid of the 24, get rid of the 30. So at least I've got at least a couple of examples there. Then we want to do the common factors of 180 and 750. And again, we're looking for numbers that divide into both those numbers, leaving no remainder. And they're both even, so we're going to go for 2, 3, 5, 6, 10, 15, and 30. So which is the biggest number that appears in both those lists? Well, it's going to be 15. Then moving on to question 8, it says x equals 3 squared times 5 and y equals 2 times 5 squared. Circle the lowest common multiple of x and y. Now, again, several ways in which you can do this, but I would say probably the most one that comes to mind quickly is just to actually work out what these numbers are. So this is 9 times 5, which is 45, and this is going to be 2 times 25, which is 50. So what I'm looking for is the lowest common multiple of 45 and 50. Now, the easiest one to go for out of these options is definitely going to be, well, 5 doesn't go into it, 30 doesn't go into both, but 450 will, because it's 45 times 10, and it's going to be in the 50 times table because it ends in a 50. For question 9.8, it says write 280 as a product of its prime. So again, what you want to do is draw a factor tree if it's a non-calculated paper. So I'm going to do, and again, your factor tree might be completely different to mine. There's always several ways in which you can do it. And once you've done your factor tree, it's then just a case of writing it using indices. So I've got 2 cubed times 5 times 7. Now, if I had access to a Casio calculator, which most people have, and let me just reset that. There we go. And to do this quickly on your calculator, just type in 280, press equals, then shift, and then fact. And it should come up with the exact same answer if you've done it correctly. And I could just write that down, and there you go. If it's on a non-calculated paper, again, obviously, then you need to draw a factor tree. But if it is on a calculated paper, I would say you don't need to draw a factor tree. And if it's worth more than 1 mark, which this is worth 2, I would say you'd probably knock a mark off if you didn't write it using indices or if you missed out a factor. Let's move on to question 9b, which I believe is our last question. It says 588 equals 2 squared times 3 times 7 squared. Work out the highest common factor of 280 and 588. So here, if I write down 588, which is 2 times 2 times 3 times 7 times 7, and we've already done 280, as 2 times 2 times 2 times 5 times 7. And then all I need to then do is circle the ones that appear in both lists and then pick one line. So the HCF is going to be 2 times 2 times 7, which gives me an answer of 28.